Okay, today we're going to look at some problems from section 3.6 in our textbook, solving linear inequalities in two variables. So here we have a inequality y is greater than negative x squared minus 2x plus 15. And so the idea is we're looking for a set of points, coordinates, that when we substitute them into this inequality, the y-coordinate will be greater than the x-coordinate with all of these operations. And so we're going to have a shaded area. There's going to be potentially an infinite number of points, coordinates, that make that true. Okay, so the first thing we want to do is to graph this. And there's a couple of ways to go about it. What I'm going to do is I'm going to factor out a negative. I'm going to see if I can find x-intercepts here. So almost as if this is an equation. So plus 2x minus 15. And so we end up with x, let's see, plus 5 and x minus 3. And so x equals negative 5, x equals 3, right? We can divide both sides by negative 1, and we still end up with 0. So we know we have x-intercepts at negative 5 and at positive 3. So there's two coordinates. We always want to find the vertex. And so the vertex, the x-coordinate, negative b, so negative 2 over 2a, so 2 times negative 1. So 2 over negative 2 or negative 1, so negative 1. And when I substitute negative 1 back into the equation, we end up with 16. So here's 10, 11, 12, 13, 14, 15. And I know that's my y-intercept, so I'm actually going to put that point there. So we have negative 1, 16. And since I went 1 there, I'm going to go 1 here. And there's my point of symmetry. So here is our parabola. I'm going to go a couple of points to be a little more accurate in here. So if I go 2 to the left, 1, 2, 3, 2 squared. 2 to the right, 1, 2, 1, 2, 3, 4. And I'll go 3 and 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And same on the other side. Okay, so here's the general shape of our parabola. Notice that it's only greater than, no equal to. So that means we're not going to include points on the parabola. So we're going to draw either, you call it a dashed or dotted parabola, because this indicates, like an open circle on a number line, that we're not including the points on the circle. All right, so now it's going to either be all the points, what I will call on the inside or on the outside, that would satisfy this inequality. So we need to test a point. And as long as we don't pick a point on the parabola, because a point on the parabola would make it equal and that wouldn't help us. So I'm going to choose the origin. So 0 is greater than negative 0 squared minus 2 times 0 plus 15. So we end up with 0 is greater than 15. Well, we know 0 is not greater than 15. So here the point 0, 0 is on the inside. And since that point does not make it true, that means all the points on the outside, the other side would make it true. And if we had tested a point on the outside, we would have seen that would have made the inequality true statement. So there is a graphing or solving any inequality in two variables, or a quadratic one. Let's look now at a system. So here is a system of inequality. So we're going to graph two parabolas, and what we're looking for is the overlapping region, the area shaded where both shaded regions overlap each other, and that will be the solution to the system. Okay, so our first one, a fairly simple parabola, right? We take our parent graph and move it down 4, and because the leading coefficient is a 1, we can go left 1, up 1 squared, left 2, up 2 squared. And again, there's no equal to. And I'm just going to go one more set of coordinates, even though I already have 5. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so again, we have either a dashed or dotted, depending on the phrase you want to use. So there is that parabola. If we test a point, so if I choose 0, 0, 0 is greater than 0 squared minus 4. 0 is greater than negative 4. Well, that is true. So I don't want to start shading yet, but I do know that if I shade, if this was by itself without the other inequality, that we would be shading here on the inside. But we still have this other one that we need to graph, and then again we're looking at the overlapping region. Okay, so I'm going to do similar to what I did before. I'm going to set it equal to 0. I'm going to factor out the negative. So x squared minus 3x minus 4. Divide both sides by negative 1. And when we factor this, we get x minus 4, x plus 1. So we have x-intercepts at 4, 0 and negative 1, 0. So there's the negative 1, 0. Here's the 4, 0. All right, we want to find the vertex. So again, I'm going to go negative b over 2a. So I have negative 3 over 2 times negative 1. So negative 3 divided by negative 2, that's 3 halves. So 1 1/2. And when I plug it back into the equation, we end up with 6 1/4. So not easy to graph, but we'll get it done. So here's 3 halves. Here's a little bit more than that, 6 1/4. 2 more points. I know the y-intercept is 0, 4. And since I went 1 1/2 to the left, I'm going to go 1 1/2 to the right to take me to 3. So we have 3, 4. So now we do have an equals to. So it's less than or equals to. So this is a solid. Okay, so there is the overlapping parabolas, but now again we need to test a point for this one. So there was that testing point over here. I'm going to choose 0, 0 again since it's not on the curve. So 0 is less than or equal to negative 0 squared plus 3 times 0 plus 4. 0 is less than or equal to 4. Well, that is true. So both of those are true statements. Excuse me. So I would want to graph, or shade rather, wherever 0, 0 is on both. And so you can see that it ends up being this enclosed region. And we want to make sure, again, that we're not on that dotted portion. So here is the overlapping area. So the coordinates in this shaded region would satisfy both inequalities. All right, let's look at one more problem. We're going to look at a word problem involving inequalities. And it says here, a rectangular playground must have a perimeter of 320 meters and an area of at least 5,000 meters squared. What are the possible lengths of the playground? Okay, so I'm going to draw a diagram because I always think that's helpful. And it's a rectangle. So opposite sides are equal. So I'm going to call each of those sides x and each of those sides y. So the perimeter has to be 320 meters. So our perimeter would be 2x plus 2y. And the area has to be at least, so that's a greater than or equal to. So, and the area is x times y is greater than or equal to 5,000. Okay. So now, in trying to solve this inequality, we have two variables. We're going to use this equation, and we're going to solve for a variable, substitute it into this equation, so then we end up with an equation with only the one variable. So I'm going to solve this one for y. So I'll subtract 2x, divide by 2, and now for y, I will substitute 160 minus x. And when we distribute, we get 160x minus x squared is greater than or equal to 5,000. Okay, so I'm going to set this up as a quadratic greater than, or rather less than or equal to 0. So here's what I'm going to do. I'm going to subtract the 5,000. And because I'd rather deal with a positive, it doesn't really matter. I'm going to multiply that by -1. So x squared minus 160x plus 5,000. And remember, anytime we multiply an inequality or divide an inequality by a negative, we switch the sign. Okay, so here's what we know. We have this parabola that opens up, and we'll look at it on a graphing calculator here in a minute. And in general, this is what our graphing calculator looks, or our quadratic looks like. Okay, there's x, there's y. Okay, so the values of x that will solve this inequality are the ones that are less than or equal to 0, or at least when we plug the x values back into the equation, it will be less than or equal to 0. Well, so here is the values that make it equal to 0. And here is the area where we find less than 0, right? All of these are y values less than 0. So any x value between this, which I'll call x1, and this point, which I'll call x2, would satisfy that. So really what we need to do is find the zeros of this quadratic, and then know that anything in between will satisfy this word problem, both of these inequalities. Okay, so here's our calculator, and there's our equation in y equals, right? We have x squared minus 160x plus 5,000. And I had to play around with the window here, and that's one of the things that you have to do. Our calculators don't come set up for that kind of thing, and so here's what I did. And this took me probably about 30 seconds of putting in a couple of different x mins and maxes and y mins and maxes to be able to see the full graph. And again, it's just something you have to play around with. And so there's the graph. So here is the x1 that I showed you on the paper over here, and there's the x2. So any x value in between those two will satisfy this inequality. So we're getting to find the roots was what we're finding, or zeros, second calc. Go to 0. It wants a left bound. I'm going to start by finding the left root. And I'm looking at my y values. I'm below the x-axis. There I am now. I am above, so I am to the left. Now I'm going to move to the right for a right bound. I see my y values below, so I'm to the right. I hit enter, and I use that as a guess. And notice we have 52.58. So for our purposes, I'm going to say that one is 43 meters. And I'm going to say that because we're going to say that all of our answers should be in integers, because we're not going to make a rectangular garden that's not in integers. All right, and then we're going to find the right one. So again, second calc, 0. And I'm moving. You're watching your y values. They're getting smaller. Now notice they're starting to get larger. We're getting closer and closer to that x-intercept. And up, we're above. So notice I am below. The y value is negative. So that's going to be my left bound. I move with the right arrow. Now my y value is positive, so I am above. So I'm going to hit enter. And now I'll use that as a guess. So again, 117.416. So I'm going to call that 117. So here's what we're saying is that as long as the x coordinate, or x, this portion of the rectangle, is anything between 43 and 117, this would work. So let's look at some examples. Let's say I pick 50. So how would that work here? So if I use 50, we know, whoops, let me get back on the screen here. Because of the fact that it all adds up to 320, if x is 50, y has to be 110, right? I've substituted 50 for x. 160 minus 50 is 110. And when we add all up, that's 320. So now, does this give me at least 5,000 as an area? So if I go back to my calculator, 50 times 110, notice it's 5,500, that's at least. And so you could pick any x value between 43 and 117. And so I will say, write it this way. And you plug it back in, you get your y, you determine the dimensions of your rectangle. So any x value or any side that's between 43 and 117, the other side you would determine based on this equation, you would have an area of at least 5,000 square meters. So I hope that helps. We'll see you soon.